The Gravity Well. Chapter 1. The Noise Floor. I signed the logbook at 2111, and the ink wobbled in a way the seismometer would have called a joke. The Livingston air was thick even in February, a wet chill that crept under the sleeves when you walked the berm from the control room to the corner station and back, checking doors, looking for the ordinary reasons things go wrong: wind, wildlife, human impatience. Night shifts at LIGO are a kind of agreed-upon solitude. You inherit a machine so sensitive it can feel a supernova from a billion years away, and somehow also a raccoon that learned to love the YN trash bin. You make peace with both truths. You learn to listen to the noise before you try to hear the signal. I brewed bad coffee and opened the trend panels. Squinting against the soft blue glow, I slid windows into the familiar architecture: interferometer power, differential arm length DARM, common arm motion, end-test mass suspensions, seismic channels, the environmental monitoring PEM, accordion of accelerometers and microphones and magnetometers, each with its own moods. Tonight was repeatable: low wind, no storms in the Gulf, microsysm quiet, anthropogenic noise tapering since the plant down the road shut for maintenance. Good conditions for a calibration run. I'm Elias Nadir. My job title changes depending on who is asking: data analyst, calibration lead, interferometrist. But most nights it means shifting the instrument from one precise state to a slightly more precise state, and documenting the difference as if the universe cares about our decimals. At 21:30 on the dot, I injected the first narrowband calibration line into the DARM channel. A faint known tone slipped onto the backs of the photons racing the 4-kilometer arms. A whisper to make sure our ears were tuned. The tone came back exactly where it belonged: amplitude within spec, phase within the tolerances I could justify without arguing with the day team. I logged the numbers, took a sip, and pulled up the raw channel for curiosity's sake. Everything looked good. It usually did, until it didn't. I pinged the corner station on the radio purely to hear another human voice, even if it crackled. "Corner Nadir, you good on the ITMY watchdogs?" "Green and sleepy," came Rose's answer. "No trips in the last hour. You're clear." "Copy. We run checklists because humility is cheap and downtime is not." I worked through the injection lines, adjusted whitening filters, nudged the power recycling cavity length until the lock felt like it would survive a butterfly thinking too loudly. A mosquito circled the desk lamp as if trying to measure the beam. At 22:07, the first anomaly arrived. I didn't recognize it as such. It was a small low swell in the DARM spectrum, a knot in the baseline like the tide inhaling somewhere deep. I flagged it in my head as microsysm misbehaving, or a truck a county away crossing a bridge the seismometers didn't love. The PEM channels were quiet. The swell receded. I logged nothing. The human brain is a poor instrument. I say this knowing I've trained mine to notice when a line is a little too straight. Still, it wants stories more than statistics. The machine is patient. It will wait until you stop telling yourself the easy story. At 22:19, the swell came again, slightly higher and cleaner. I frowned and leaned closer as if that could shrink the variance. The frequency sat well below the band where we expect astrophysical events. It was a shoulder, a low-frequency lump, neat in a way that felt like someone had ironed a wrinkle in fabric that should have had no taste for irons. "Pemcross?" I muttered to no one, and dragged the overlays into place. Nothing. The microphones were quiet. The accelerometers were textbook, magnetic channels flat, wind still low, the flag outside hardly remembering how to ripple. I scrolled through the minute trend data and marked the time with a yellow line. The swell faded. Calibrations make you territorial. You want to own every quirk and name it. Noise with a name becomes a friend, something you can seat at the table when results get presented to the collaboration. But unnamed noise is a ghost sitting in an empty chair, and everyone pretends not to see it. At 22:41, the swell returned, clean enough that I stopped the injection tones to give it space. I watch the Dharm channel like you watch someone you love sleep, convinced your attention changes the event. The swell was narrow. It rose, held for 2 minutes, then smoothed back into the baseline like a good lie. Rosa's footsteps arrived in the doorway before her voice. She leaned on the frame, hair tucked under a beanie that had seen better winters. "You've gone statue again." "What are we babysitting?" I gestured at the screen. "Darm's got a hobby." She came closer and bent until her nose nearly met the glass. "PEM?" "Nothing correlated. Magnetometer's flat. Seismic's boring. Local traffic's dead." I pulled the live feed from KAGRA just to keep myself honest, but the latency's murder and they're running a commissioning script. She watched another moment. "Could be thermal drift in the end station." "Air conditioning cycles?" "Logged and steady." I clicked through. "If it's HVAC, it's shy." "Did you check with Virgo?" I hesitated. The collaboration is a web of politeness and latency. I checked their status page. Green. No alerts posted. Rosa shrugged. "Then it's probably us being interesting for once. Mark it and see if it likes you enough to come back." She grinned and pushed off the frame. "Radio if it turns into a ghost story." I rolled the chair back and forth under the desk, the way I do when a problem pretends not to be one. The swell had timing now. The intervals weren't exact, but they were regular enough to tease. I pulled a fresh notebook from my bag, the one I reserve for thinking with a pen, which is slower and therefore sometimes smarter, and wrote the times down: 22:07, 22:19, 22:41. I wrote 12 at 22 and then crossed both out because speed is a motion, and I needed numbers. I exported a slice of the raw channel just in case this turned into a great blank wall later, and opened a script I'd written months ago for another mystery. The script wasn't clever. It did exactly what I told it to, which is the best you can hope for at this level of friendship. At 23:03, the swell came again. 4. I ran a simple periodogram and kept my face as still as possible, as if not to frighten a skittish animal. A peak emerged low, where the microsysm should have had a monopoly on irritation, but the shape was wrong. I checked the seismometers again. The Gulf was behaving itself. I did not say the word periodic out loud. It would have been a curse. By habit, I checked the power spectrum from the end test mass suspensions and their sensors. If the swell had been a controller acting up or a glitch in a coil driver, it would have left fingerprints. Clean. I checked the data quality flags. Green. I checked the almanac for tides and watched myself pretend that made sense. Tides are a thing you mentioned to prove you tried the folk remedies. At 23:15, Rosa radioed from the corner. "You still married to your lump?" "Words hurt," I said, and heard her laugh. It came again. "Want me to nudge the end yaw by a hair?" "Hold for now. If it's us, let's let us finish the confession." "Copy that." I'm going to make peace with the vending machine. The machine took her money and gave her what it wanted. Machines have always had opinions. The swell was patient. I looked at the injection plan, and the plan looked back with an innocence it did not possess. I resumed the calibration lines and watched the tone dance with a line that shouldn't have been a partner. The swell paid no attention to the tone. It had its own choreography. I wrote more times. 23:03, 23:27, 23:49. The intervals were not equal, but they hovered. I plotted the gaps and felt the itch behind the eyes that means you either drink water or make a mistake. I drank water. I made fewer mistakes. At 0006, the swell arrived and brought a friend, a second, weaker hump a little higher. This one had the good manners to nod at the PEM microphones, just a tickle, but it was too tidy for acoustics and too indifferent to wind. I copied both into the notebook like I was transcribing a conversation overheard in a foreign language. Now is a good place to say what this wasn't. It wasn't an event. We know what events look like. They are bowling balls on a trampoline across 1 billion years of goodbyes. They are spikes with a taste for drama. This was a tide, scheduled, low, patient, unremarkable to anyone but the person who had to sign the logbook and explain why the baseline had an opinion. I paged through months of trend data for nights like this, calm and competent, and found a few half-remembered shoulder lumps I'd assigned to boredom. They weren't identical, but they rhymed. I added them to the notebook. I drew a small embarrassed star next to the night last autumn when I'd chosen sleep over curiosity. Around 0040, I opened a secure chat to a colleague in Italy whose insomnia was famous. Virgo Green, I typed. We're seeing a low swell, might be our HVAC whispering sweet nothings. She replied with a sticker of an owl and then actual words. Quiet here. Noise floor is behaving. What frequency? Below 20 hertz. Too clean for microseism, PEM's not flirting. Comes in windows, wrong for traffic. Might be nothing, probably nothing. Probably, she said, which is collaboration for your problem, my love. Then, a minute later, hold, please. I held. Virgo's latency for raw channels isn't chat-friendly, but my colleague has access that I don't. The cursor blinked without shame. I watched the lab. The vacuum pumps made a sound like someone's grandmother sleeping. The coffee got worse. It's faint here, she typed, but I think I see your shoulder when I integrate. Could be coincidence. Could be you're cursed. Have been since birth, I wrote. Thanks. Mark it. If it repeats, we gossip properly tomorrow. I thanked her and closed the window. I made a note in the official log with the kind of humility that doesn't cost a reputation later. Possible low-frequency environmental swell, uncorrelated with PEM, monitoring, calibration ongoing. The swell returned at 101, then again at 123. By 2:00, I had enough points to plot something that would simmer rather than boil. I ran cross-correlations against the magnetometers again. If there was a motor within miles misbehaving, the magnets usually knew. Nothing. I tried to fit the intervals with a naive sinusoid, then with a composite of 2. The RMS errors were the sort that would make a student blush and a professor ask about lunch. I stopped myself and did the sensible thing. I tagged the raw frames. I spun up the archiver to pull a day's worth of data around the windows I'd marked. I started a note in plain English that my future self wouldn't despise. And then I stood up, walked outside, and listened to a stretch of Louisiana that had nothing to say about gravity. The night air had a different texture beyond the control room's constant hum. Out there, the world has opinions of its own. The berm sloped away into flatness. The stars were a modest show behind a haze that didn't feel like rain. Somewhere a frog stated a thesis. I walked the first 100 meters of the X-arm where the laser travels invisibly inside a pipe big enough to make comedians about Star Wars. A rabbit bolted from the grass like a misinterpreted data point. Rosa joined me with a bag of vending machine sins. Your lump send you to the philosophers? Only for air, I said. Sometimes the machine is too much machine. She passed me a dubious package. They call these cookies. What's the verdict? Still undecided, I said. I meant the cookies and the lump. We stood there a while. The corner station's red light indicated locked and hopeful. The wind made an argument for spring. The world continued to be a place where gravity is a constant, and people borrow that certainty for everything else. Back inside, we swapped shifts at the keyboard fairy tale style. She took the next hour's watch while I prepped the morning email in my head, the one that says, we saw a thing, probably nothing, more later. Conservatism is a culture. It keeps us from declaring victory when all we've done is name a ghost. At 3:12, the swell arrived on the early side, and I didn't like its manners. It rose faster, held longer, and felt like it remembered how. It was still small, still ignorable if you weren't me, but it had made a choice. I scrolled through the trend panel and felt my face become a quiet place. I compared to Virgo's overnight summary. Nothing flagged there beyond a minor alignment dance at 1:40 their time. I wrote down 3:12, and underneath it I wrote not an event, because I didn't trust the part of me that wanted stories. Facts first, then conjecture, carefully caged. Around 4 a.m., Rosa dozed upright in her chair with the headset still crooked around her neck. I envied her and didn't. I polished the morning note and put in the sentences that keep collaborators from sharpening sticks. We propose additional PEM audits. We will cross-check with local infrastructure schedules. We will verify with environmental injection. We discourage speculation at this time. It read like a hymn we all knew by heart. I saved a copy on my personal drive, not because I intended mischief, but because I know the shape of forgetfulness. I also copied the raw time slices into a folder named Oddities that I told myself was for pedagogy. Future students love oddities. They remind us that the instrument is in conversation with the world, and we are the eavesdroppers, not the authors. At 5:06, the swell made its last visit of my shift. I watched it with the kind of attention you give a leaving train, not because someone you love is on it, but because you want to be sure you've remembered the face of the conductor correctly. It rose to the same polite amplitude, faded on the same polite schedule. I let my shoulders fall the way they do when the body realizes it had been braced without permission. I wrote the last line of the night in my notebook. If it repeats, it deserves a name. Then, smaller. If it doesn't, it deserves a story. Dawn in the control room looks like forgiveness. The monitors bleach a little, the shadows admit defeat, and the machine seems less like a living thing that might bolt and more like the thing it is, the cleanest ruler we can make against an indifferent universe. You can love an indifferent universe. It's honest with you. There are days it lets you measure something you don't understand. There are nights it lets you practice being ready for the day it will. Rosa handed me her headset and I signed the logbook out at 6:01, the ink steadier now that the world had returned to color. "You going to sleep?" she asked. "I'm going to pretend," I said. "Then I'm going to annoy Virgo with numbers." She grinned. Dream of straight baselines. I stepped outside into a morning already convincing itself it would be hot. The long arms radiated away into line and horizon, and the birds decided shifts didn't apply to them. I put the notebook in my bag, felt the hexagon of its corners against my spine, and told myself a kind lie, that I was carrying home a mistake, that I would open it in a few hours and find that the swell had been the most interesting kind of boring. The noise floor is a floor for a reason, my first mentor used to say. Don't dig for treasure under it. You'll drown. In the parking lot, the pilot lights of a pickup truck blinked awake. The driver, one of the day crew, lifted a hand that meant both greeting and continuity. The baton passed invisibly, the machine continued its quiet, and the universe went on saying what it has always said, fall. On the drive home, the radio murmured weather and traffic and small crimes. I turned it off at the curve by the cypress trees. The world is too full of signals to hear any of them for long. I recited the times again in my head the way a child recites the alphabet, as if repetition could conjure meaning. 2207, 2219, 2241, 2303, 2327, 2349, 00:0601:01, 123, 312, 506. There was a pattern there. There is always a pattern if you look hard enough. The job is knowing which ones belong to you. I slept 3 hours and dreamed about straight lines refusing to meet. When I woke, I made a pot of coffee that tasted like grudges and opened the laptop. The house was quiet in the way you notice only when you've spent the night with machines. I logged into the collaboration servers, pulled the frames I'd marked, and sent a polite set of questions to 3 people who would forgive me if the answer was, "Check your HVAC again, Elias." Then I took a slower breath than usual and opened my notebook to the first page. Under the title I'd scrawled at 9:12, Night Check Calibration, I wrote 4 words I knew I would later wish I'd chosen more carefully. Low-frequency swell? Periodic? The unasked question sat next to it, half-formed, unhelpful, hungry. I put the cap on the pen and left it there to starve. By noon, the replies came in the sequence I expected. A joke about ghosts, a request for raw slices, and a reminder that Virgo had seen something faint the week before in a different frequency band that they'd blamed on construction equipment 20 kilometers away. I breathed a little easier. Construction equipment is a friend you can identify by footprint and lunch breaks. I spent the afternoon playing fair. I treated the swell like a stranger at a public meeting who'd raised a hand politely. I gave it time. I asked it the questions we're trained to ask. I interrogated my own bias and found what all scientists find when they are honest: an inconvenient wish to be the first to know a thing. By evening, I had a list of experiments to run the next night: deliberate PEM injections to test acoustic coupling, sweeping the calibration lines to look for intermodulation products, toggling non-essential equipment one at a time, and a masochistic plan to sit the entire night with no headphones and no music, so there would be nothing between me and the hum of the instrument except distance. At 1938, I set a reminder to email the GPS timing team to ask for a cross-check. Any oddities in the network's clock drift around the hours I'd marked. It was a long shot. It was also the sort of question that made me feel like I wasn't pretending. As the sun sank behind a stand of trees that had learned the schedule of our shift changes, I stood in my kitchen and told myself again that the swell was a story I would tell as a lesson in patience. "We chased a ghost," I would say to a student a year from now. "We learned the instrument better because of it. We learned ourselves better because of it. Not every swell is a storm." If I had known the shape of the future, I would have written more carefully. I would have saved different files and thrown away others. I would have slept. Instead, I closed the laptop and washed a cup that didn't need washing. The phone buzzed with a message from a number I didn't recognize. It was a photo from the end station, a blurred smear of a rabbit that had mistaken the corner of the lab for a place the world couldn't find it. "New intern." I laughed. I saved it. I marked the time in my head without meaning to. The machine would be waiting. The universe would continue indifferently. The swell would either return or not, and either outcome would be ordinary in the way all beginnings are ordinary, which is to say invisible until they aren't. I set my bag by the door and on the way to the light switch paused long enough to tap the notebook's cover with the back of my fingers, as if it were an animal I didn't want to startle. Then I went to meet the next night, eager for the comfort of being wrong. Chapter 2. The Drift. The swell returned the next night, as if the machine had been waiting for me to show up again. The baseline rose, held, and dropped with the same calm indifference. Rosa called it my shadow. I called it a problem. The collaboration called it unconfirmed. Over the following months, the swell grew familiar. Sometimes it arrived early, sometimes late, but never gone. Other sites began to notice. Virgo saw it faintly, Cagra only when the noise gods were merciful. The times didn't match perfectly. The path of gravity is not the path of light. Even so, the pattern teased coherence. We ruled out what could be ruled out. Instrumental crosstalk, digital ghosts, servo oscillations, magnetic coupling, seismic drift, even the way the air conditioners sighed at dawn. Each explanation died politely under scrutiny. The swell stayed. I remember the day the data group added a color to the spectrogram: blue for baseline, orange for calibration, red for anomalies. The new hue for this one was white because it refused to pick a side. It sat there like a gap between choices. My notebooks filled with numbers written too neatly. I drew the same graph a dozen times, each more honest than the last. The intervals shifted slightly with the seasons, suggesting a source that wasn't on Earth. The amplitude changed with lunar phase, suggesting it might have been, after all. The universe is fond of taunting certainty. By January, we had cross-checked with pulsar timing arrays. Nothing correlated. The radio astronomers sent sympathy disguised as sarcasm. "If gravity starts singing, call us for the encore." When Virgo finally confirmed the same periodic low-frequency swell, within tolerance of our timestamps, the conversation changed. It wasn't just Livingston's ghost anymore. It was global. Meetings multiplied. The collaboration's internal forum flooded with plots, counterplots, and cautious excitement. Every time someone wrote the word correlated, a dozen reviewers sharpened pens. We spoke of systematic uncertainties, calibration mismodeling, and cross-site coherence. Beneath the jargon ran a quiet current. What if this is real? The anomaly's source direction triangulated somewhere along the plane between Mars and Jupiter, too far to be geological, too close to be cosmological. The absence of an optical or radio counterpart only deepened the intrigue. It was a gravity-only guest. I flew to Italy that spring to sit with the Virgo team. The detector near Pisa hums a different song than Livingston. Drier air, gentler ground, cables that smell faintly of ozone and wine. The Italians approach calibration like art restoration, delicate, patient, reverent. We sat in a control room that smelled of coffee and arguments, aligning plots until they confessed. The anomaly's frequency drifted with a pattern that didn't fit tidal forces or thermal cycles. Someone joked that it behaved like an orbit, but no known mass matched its pull. We tested for everything that could impersonate nature. Passing asteroids? None near enough. Solar tides? Wrong shape? Instrument cross-modulation? Implausible given the detector's isolation. Human interference? Always the favorite suspect, always the least likely culprit. Our lasers are better liars than we are. When we folded the data over months, a weak harmonic appeared, a secondary peak, barely visible but stubborn. That's when we started whispering new physics, not allowed in meetings, not yet, but in hallways and between shifts where hope can hide behind professionalism. There was one night in the Virgo canteen when the wine was bad enough to be honest. Someone said, if this holds, we're looking at dark matter. Moving dark matter. We laughed too loudly. Then no one spoke for a minute. We didn't want to break the sentence by examining it. I returned to Livingston with half a notebook of Italian equations and a sense that the floor under my feet had started to tilt, gently but persistently. I spent evenings plotting the amplitude over time, pretending it was a tide chart. There were months when it almost vanished, then returned stronger as if the source breathed. Rosa said, if it's dark matter, we should send it a thank you note for finally showing up. It's not dark matter, I said automatically because denial is the currency of caution, but I wasn't sure. By summer, the collaboration's Central Committee released a preprint draft, internal eyes only. The language was deliberate, every adjective litigated. We report a persistent, low-frequency gravitational anomaly observed at multiple sites. The signal's coherence suggests an unmodeled astrophysical source or a previously undetected local mass distribution. Unmodeled astrophysical source, a phrase that means we have no idea, but we'd like the universe to think we do. The draft went through 9 versions in 2 months. Each time the wording grew more conservative, even as the data grew more convincing. We're a species that apologizes to itself when it learns something new. The source location stabilized, a broad region near the inner edge of the asteroid belt. The gravitational amplitude implied mass far greater than any cataloged body, yet nothing reflected sunlight there. The absence of light is sometimes louder than presence. Lisa Pathfinder's archived data was reanalyzed. No trace of this signal back then. Whatever it was, it had grown or moved since 2020. Motion meant dynamics. Dynamics meant a mechanism. I began writing a side paper, purely theoretical, exploring whether dark matter could transiently cluster into self-gravitating filaments. The math almost worked, which is the most dangerous result a physicist can get. It means you're close enough to believe, but not enough to be right. Night after night, the swell repeated. Its profile sharpened as detectors improved. The collaboration agreed on an informal name, the Belt Anomaly. No one liked the acronym possibilities. We plotted energy density estimates. If the mass distribution were real, it could account for a fraction of the missing mass in our local galactic neighborhood. Not all dark matter, just a taste. Enough to make careers, rewrite textbooks, redraw the universe's balance sheet. The Belt Anomaly workshops began, first virtual, then real. Conference rooms filled with equations that wouldn't sit still. Young postdocs smiled the way people do when history is flirting with them. The first cross-correlation with planetary ephemerides showed a whisper of orbital deviation in minor asteroids. Within error, yes, but too consistent to dismiss. Something out there was tugging. I remember a night when Rosa and I stayed long after the others had gone, comparing datasets. She balanced her chair on two legs, staring at the plot. If this is dark matter, it's more talkative than expected. Dark matter doesn't talk, I said. Maybe we just never listened on the right channel. The coffee machine wheezed agreement. We didn't notice it had grown quiet outside, the kind of silence you get when humidity eats sound. The lab felt smaller, like the walls had stepped closer to watch. By the end of 2028, we had ruled out everything human and everything ordinary. No known planet, asteroid, or comet accounted for the pull. Solar tides were wrong by orders of magnitude. Instrumental error had been beaten to death and buried under audits. The signal persisted, precise and unembarrassed. Funding agencies love precision. Proposals tripled. LIGO became a celebrity again. We hired new analysts who treated the anomaly like a mythological creature glimpsed through fog, not disbelief, just reverent skepticism. I gave a talk at a small conference in Geneva. My slides were a collage of honesty. Here's what we see, here's what we don't understand, here's what we're trying next. Someone from the audience asked if I believed it was dark matter. I answered truthfully, I believe it's gravitational and I believe it's real. Everything else is grammar. That line got quoted more than it deserved. Afterward, in the hotel bar, a cosmologist from Cambridge told me quietly, if this holds, it's the beginning of the end for the lambda CDM model. The universe will need new adjectives. She smiled, but her eyes didn't. Theoretical people can smell paradigm shifts the way sailors smell storms. Back at Livingston, we installed new seismic isolation upgrades. The detector's sensitivity crept lower, the noise floor smoother. The anomaly remained, stubbornly consistent. The cleaner we made the machine, the sharper the anomaly became, as if clarity invited it closer. That paradox didn't escape me. The more precisely we looked, the more the universe provided to look at. In May, we began discussing an orbital mission, an interferometer in space, free from Earth's murmur. Early design studies called it LISA-2, though the real one was still a few years away. Engineers argued over laser stability and arm length, while theorists argued over naming rights for an effect that didn't officially exist yet. I found myself speaking at panels about localized gravitational resonances. I used that phrase because it sounded safer than moving mass we can't see. Journalists loved it. They always do when science sounds like poetry by accident. At home, I kept my own counsel. The notebooks filled faster, margins hosting equations that tried to prove the impossible consistent. The signal had substructure now, faint overtones nested within the main wave. If this was a dark matter filament, it was resonating. Self-interaction, self-organization, terms that made cosmologists argue and experimentalists lean forward. The nights were shorter that summer. Rosa joked that we'd make more progress if the anomaly took weekends off. I didn't laugh. Some part of me had begun timing my life to its rhythm. The swell came, like breath. It came through storms, through holidays, through weeks when the detector was off for maintenance, only to be waiting in the data backlog when we rebooted. It was as faithful as gravity itself. The data team began fitting models that gave it a quasi-orbital period around the sun, roughly 18 months, eccentric and odd. If that were true, it would pass nearer to us next year. We debated the implications like gamblers learning a new game. At one meeting, someone asked what would happen if it got too close. The room laughed. I laughed too because that was the social rule, but I wrote the question down in my notebook. What happens when gravity moves differently nearby? I didn't have an answer. No one did. The equations behaved beautifully until they didn't. That's physics. That's life. Still, there was joy in the work. The numbers sang, even if we didn't know the lyrics. When the first draft of the public paper circulated, I read the abstract 3 times. It was cautious, balanced, boring in the way only history can be before it knows its history. We report a persistent low-frequency gravitational signal consistent with a massive non-luminous structure in the inner solar system asterisk. That was the sentence. That was how it began. The word structure made my pulse skip. I closed the document, opened a new page in the notebook, and wrote, "The floor moved." It wasn't poetry, it was observation, and for now that was enough. Chapter 3: The Resonance. The anomaly settled into our lives the way weather does, a constant background that shaped everything we built without asking permission. By the time 2029 rolled over, no one in the collaboration called it a mystery anymore. It had become an equation, a data set, a proper noun. We were measuring the unknown as if naming it could make it ours. I began traveling more. Conferences multiplied like offspring of curiosity. Geneva, Tokyo, Pasadena, Delhi. The same slides and different accents, the same graphs tuned to local optimism. Everywhere the story was the same, a low-frequency gravitational signal repeating across detectors, stable, coherent, gravitationally loud but visually silent. We called it the belt anomaly because calling it anything else felt like bragging. It was not mine anymore, if it ever had been. It belonged to the world now. The first time I stood before a full auditorium and presented the data, I realized I'd been living with a secret that everyone wanted to adopt. Questions came in waves. How stable is the frequency drift? What about coupling to solar wind? Could it be a macroscopic quantum effect? Someone asked about exotic compact halo objects, another about rotating cosmic strings. Theories spilled out like confetti. For the first time in my life, the words dark matter felt almost polite. The anomaly had begun to resonate, literally. When we stacked months of data, harmonics emerged, faint but real. It was as if the source was a string plucked by space-time itself. That idea didn't make the papers, not officially, but it haunted every hallway conversation. Back at Livingston, the nights blurred together. The detector ran cleaner than ever, the baseline so smooth that even the coffee tasted aligned. Rosa and I took turns living on caffeine and hope. She claimed the anomaly's harmonics hummed at the edge of audibility if you sped them up a few million times. I told her she was projecting. Then she played me the audio file and I stopped pretending not to hear it. A long, slow note that rose and fell like breath. People started calling it the hum. Lisa's early prototypes caught it too, faint but consistent. Gravitational resonance was no longer theory, it was data. The global map of our detectors looked like a nervous system lighting up. Each new instrument joined the chorus: India's Indigo Array, the South African mini-interferometers, even cryogenic testbeds in Antarctica that shouldn't have seen anything did. We were listening to the same heartbeat from different corners of the planet. Governments began funding us the way they used to fund wars. Budgets that once required petitions arrived overnight. The anomaly unified nations in a way politics never could. For the first time in decades, science became spectacle again. Kids drew waveforms in chalk on sidewalks. A pop singer released a song called "The Dark Between Us," sampling the sped-up signal. I pretended to hate it. Secretly, it moved me. But for all the glamour, the work stayed tedious. For every discovery, there were 100 calibration meetings. We built better timing synchronization between observatories, refined the global GPS baselines, modeled environmental coupling to exhaustion. Each refinement made the signal clearer, not fainter. The cleaner the instrument, the louder the hum. By mid-2030, a working theory emerged. The anomaly was a coherent structure of self-interacting dark matter, oscillating in a stable configuration around the sun. It wasn't orbiting in the classical sense, it was vibrating, a gravitational standing wave locked between orbital resonances. The math almost worked. Almost. Our equations fit the data until the fourth decimal, then slipped sideways into mystery again. That almost became the world's favorite word. I joined an ESA symposium in Madrid that summer. They unveiled new gravitational models derived from planetary tracking data, tiny deviations in the orbits of Mars' moons, subtle irregularities in spacecraft telemetry. Every clue pointed to something massive but invisible, passing through the inner solar system on a periodic timescale. The models were beautiful in the way unsolved problems are, elegant until proven wrong. After my talk, a planetary scientist named Ortiz cornered me with a grin too tired to fake. "You realize," he said, "we're looking at the first dynamic dark matter system ever observed. It's not just mass, it's movement. The universe isn't silent after all." I nodded, but part of me still didn't believe him. The laws of physics had always been enough. Now they seemed to be making room for a guest. Later that night, we drank on the hotel rooftop and argued about what it meant. Ortiz believed we were witnessing dark matter self-organizing, a cosmic phase transition long predicted and finally seen. Others suggested we were catching the echo of a gravitational soliton, a stable wave particle in space-time itself. I listened more than I spoke. Every idea seemed too grand and too fragile all at once. When I returned home, the inbox had tripled. Data requests, collaborations, media inquiries, conspiracy theories. Everyone wanted to own a piece of the invisible. The collaboration's central paper went public that autumn. The press release was cautious, evidence of a persistent gravitational structure within the inner solar system. The world translated caution into wonder. Headlines declared the discovery of moving dark matter. Stock photos of galaxies multiplied. The phrase trended. Politicians mispronounced it. The global temperature of excitement rose 1 degree. Within the scientific community, debate replaced oxygen. Could dark matter interact with itself strongly enough to produce coherent gravitational waves? Could it oscillate at frequencies measurable by LIGO class detectors? Could it even exist this close to the sun without collapsing? Each question sprouted 1,000 papers. The data team, my team, became the unwilling center of it all. We spent endless hours cross-checking timing errors, noise subtraction algorithms, phase correlations. Each audit reinforced the same conclusion: whatever we were seeing was real, and it was gravitational. I remember the day Rosa burst into my office, laptop in hand, eyes bright. "Look at this," she said. "Virgo's new run. The amplitude's modulating." I looked. She was right. The waveform's peaks weren't uniform anymore. They pulsed in sequences, complex but regular. When plotted over time, the modulation formed nested harmonics, like chords built atop a single note. I felt my scalp tighten. It was structure. "We might be seeing subcomponents," she said. "Dark matter filaments weaving together, a resonance lattice." The phrase sounded absurd even as it thrilled me. I tried to argue caution, but she was already running simulations. Within a week, half the collaboration was modeling lattice dynamics in dark matter fields. We debated whether gravitational self-organization could produce such order. Some said yes, citing quantum analogies. Others said no, citing sanity. The beauty of science is that it forgives arrogance until the data stops agreeing. That winter, we convened in Kyoto for the International Gravitational Conference. The city was wet with early snow. Hundreds of us crammed into halls that smelled of laptops and optimism. Presentations blurred into one another. Wavelet analyses, Bayesian reconstructions, cosmic string speculation, new sensor prototypes. Outside, tourists wandered temples, oblivious to the fact that their gravity might be slightly different than yesterday's. The LISA Pathfinder teams presented their early spaceborne measurements, tiny but definitive confirmation of the belt anomaly's harmonics beyond Earth's interference. The crowd applauded like it was a concert. I applauded too, though part of me wanted to look away. During a coffee break, a young postdoc from Caltech asked me, "Do you ever worry it's too clean?" "Natural systems are messy. This one's perfect." I smiled the way you do when you want to protect someone from their own intuition. "Perfection is just the limit of noise reduction," I said. It sounded reasonable, It wasn't true. The months that followed were a blur of peer review and preprints. Journals fought for exclusivity. Funding agencies competed for association. The belt anomaly became a brand. Theories proliferated faster than refutations could keep up. Some nights I read them like bedtime stories. Supersymmetric fluid dynamics, emergent space-time crystals, dark field coherence. Each idea was more beautiful than the last, and each almost fit the data. I think that was when excitement turned to reverence. We began to speak of the anomaly as if it were listening. Late that year, a joint NASA-ESA press conference announced a new mission concept, GRAVIS, Gravitational Resonance and Variable Interaction Surveyor. An autonomous probe designed to map the belt region's gravitational field directly. It would launch within 4 years, built from existing satellite components and far too much ambition. The announcement drew applause. The hum played faintly in the background of our data feeds, steady and unchanged. In private, I had begun to dream of it, not metaphorically, actual dreams. Standing in the control room, watching the baseline curve rise and fall like the tide, but the monitors were silent. The swell pulsed under my ribs, a heartbeat too deep to belong to me. When I woke, I could still feel it. I didn't tell anyone. Scientists are superstitious about patterns that leave the data and enter the body. In the final months of 2031, LIGO recorded the cleanest run in its history. The anomaly was unmistakable, periodic, harmonic, structured. The models that treated it as a gravitational resonance within a dark matter lattice fit best. The equations almost closed. For a moment, the universe made sense again. We submitted the paper that would later define that era. Its last sentence read, "Further study of this gravitational resonance may illuminate the nature of dark matter and the large-scale structure of the cosmos." Simple, hopeful, wrong in ways we couldn't yet imagine. When the acceptance email arrived, Rosa grinned and said, "Congratulations, Dr. Nadir. You helped find the universe's missing mass." I nodded, but inside something shifted, a faint unease that felt like the beginning of motion. The resonance continued, patient and perfect, as if waiting for us to catch up. I told myself it was the sound of progress. I told myself it was the voice of the universe finally speaking. And I believed it because belief is just a data point we haven't disproved yet. Chapter 4. The Collapse. The word collapse means one thing to an interferometer and another to a human being. In the lab, a collapse is a good thing, a curve that tightens as parameters converge, a probability that stops behaving like smoke and pours itself into a cup. In my first notes for this chapter of the story, the real one, the lived one, I used collapse to mean closure. We were closing in. The hum had grown orderly. Lisa's Pathfinder relays, the ground arrays, and the new timing baselines between GPS clusters all agreed. The belt anomaly was not random noise in local space-time. It was a coherent, repeating gravitational resonance that drifted predictably across frequency and amplitude. When we stacked the runs from across a year, the waveform locked into a shape we could fit, and once a physicist can fit a shape, they start writing poems made of equations. Our best poem was a lattice. Think of a mesh, not of wires but of gravity itself. Nodes where the curvature intensified, filaments where it relaxed, a repeating symmetry that only a blind universe could design by accident. The phrase that won the meeting in Madrid was dark matter crystallization, which made theory people purse their lips and then nod because the math, our math, nearly let it be true. Nearly is the most intoxicating adverb in science. It's the one that keeps you from sleeping and sends you to the whiteboard at 2 a.m. to move a minus sign the width of a hair. What we had was this, a coherent sublight quasi-periodic gravitational structure with harmonics. No electromagnetic signature, no thermal glow, no reflected sunlight, nothing to see and everything to weigh. The models that treated it as a self-interacting dark matter field performed best. Raise the self-interaction term and the lattice stayed up, lower it and the structure tore itself apart. Between those extremes, there was a narrow corridor where the equations behaved like adults. We called that corridor plausibility. In late meetings at Livingston, the plots looked like confessionals. Rosa would lean back with a pencil between her teeth and say, "If we take sigma to be bigger than a polite wimp but smaller than a screaming axion, the resonance sits still." We joked about wimps and axions like they were temperaments. The joke was geography. We were living in the space between them where no one had expected to build a house. More detectors joined the neighborhood. Indigo's arms came online long enough to confirm our overtones. A small cryogenic interferometer in Finland put its shoulder under our lowest frequency band and lifted. The pulsar timing arrays still wanted to be invited. Their sky was too large, our effect too local. No one held it against them. The sky is a generous host until it isn't. Gravis, the probe that had been pure press conference a year before, became a timeline with milestones and angry spreadsheets. It was less a single spacecraft than a choreography of familiar parts: cold atom interferometers, precision accelerometers, laser links, a microthruster system designed to whisper rather than push, and enough radiation shielding to survive the inner belt. The mission profile, spiral outward, match velocity with the belt region near its next perigee, map curvature directly by flying through it. I kept a picture of the bus on my wall in the office, not because I'm sentimental about hardware, but because it looked like sanity. We had an instrument to take into the dark. We had questions to ask there. Meanwhile, the data at home kept getting better. Seismic isolation improvements nibbled down the bottom of our bandpass. Timing synchronization across continents shaved microseconds into vanity. The baseline, the holy baseline, smoothed until the new graduate students started to trust it without the proper fear. We cured them by showing them bad nights from old runs full of hiccups and stumbles. The machine has a personality. It took us a decade to teach it courtesy. The resonance did not care. It continued, periodic and composed, as if it had accepted our attention and decided to become a better example of itself. That was when the first closure plots turned heads outside our circle. Take the lattice model with a moderate self-interaction term, add an eccentric solar trajectory with a long period, and feed it to planetary ephemerides. The residuals with Mars's minor moons improved. The tiny stubborn precession drifts in some main belt asteroids calmed. Even the long baseline ranging data from an old Venus mission looked cleaner when we let the lattice tug a little. It's difficult to explain to people who don't live in this house how thrilling a smaller residual can be. You stare at a scatter of points for months, endure colleagues who worship different outliers than you do, and then one afternoon the scatter narrows and the argument stops. Not because you've won, winning is a social fiction, but because the world has stopped protesting that particular sentence. We were, for the first time, correcting the solar system with a piece of invisible mass that moved where the light did not. The word breakthrough appeared in slides. Not ours. Breakthrough is a noun you let other people hand you, but in the talk titles of theorists who had never visited our control rooms, and perhaps for that reason loved us more than we loved ourselves. I'm making it sound simpler than it was. Every improvement spawned 3 new headaches. The lattice models predicted sidebands we couldn't quite resolve. The self-interaction term required values that made particle physicists itch. The resonances phase drifted with a subtlety that made us suspect we were fitting a real curve with an almost real function. The only thing worse than being wrong is being close. The press called it the Einstein-Planck bridge. My email found new ways to use the phrase "on background." A documentary crew wanted to film a night shift. We said no. A camera turns noise into theater and theater into superstition. But when I walked out to the X-end at 3 in the morning, I found myself looking up as if the lattice were a net draped across a sky that had never been mine. Old instincts die when the data lets them. In the collaboration, arguments sharpened without turning cruel. That is a kind of success. One camp, my camp most days, pushed the self-interacting dark matter lattice hard. Another preferred a gravitational soliton model. No particles, no new self-interaction, just space-time solving its own equations in a way that had gone unfavored only because no one had asked it to speak that way. A quieter minority whispered about modified gravity, but whispering was rare. The lattice fit too much to throw it away for taste. I remember a long afternoon in Pisa with Virgo's lead analyst Chiara as we lined up our phase reconstructions at a whiteboard that had surrendered to marker ghosts years ago. We watched the harmonics broaden and sharpen over the seasons like breath over glass. "There's a temperature here," she said, not meaning heat. "A variance, a softness." We added a parameter and lost our footing. We subtracted it, and the curve forgave us. The lattice wanted to be simple. The world did too. On the other side of the Atlantic, Rosa ran Monte Carlo simulations until her processor sounded like weather. She found that if the lattice had a weak gradient across one axis, the apparent modulation in our band would match the minor power fluctuations we kept attributing to mundane drift. It was an elegant theft. Take a flaw from the instrument and assign it to the sky. It held up for 2 months and then let go. We kept it anyway, as a lesson in how seductively wrong an elegant answer can be. Through all of it, the hum persisted. Some nights I wore headphones to force silence over the superstition that I could hear it. Some nights I didn't, and the superstition returned. I did not tell anyone about the dreams where the waveform marched across the backs of my eyelids and refused to be blinked away. Gravis moved from paper to metal. ESA signed off on a schedule that looked like ambition daring you to call it foolish. NASA contributed an accelerometer package people whispered about the way sailors whisper about weather gods. The mission patch showed a simple arc crossing an empty hexagon and a line beneath ad mensurum toward the measure. In our internal calls, mission people spoke in verbs, integrate, test, bake out, while we scientists spoke in nouns, lattice, node, filament. Between them ran a thin bridge called deliverables. It felt for once like the world might keep its appointments. The winter before launch rehearsed optimism. The resonance sharpened in a way our best fits predicted it would if the lattice were on an inward leg of its long orbit. That prediction, when it landed, was a quiet triumph. We had told the future to behave, and this once it had listened. In my notebook I wrote, "predictive success," then struck it out for modesty and wrote, "sanity check passed." Rosa threw a small party, a handful of us and a cake with a plot iced in shaky lines. She stuck birthday candles where the harmonics should have been. We laughed like people borrowing joy. The next day we were back at the screens, making sure the cake hadn't offended any gods with its jagged axes. If you want a single frame from those months, it's this. A late night, the control room a dim boat on a flat sea, 3 of us squinting at a plot that had finally decided not to shake. In the far corner, a printout from the Gravis team, trajectory windows, fuel margins, contingency modes, 2 kinds of faith sharing a table. We had learned enough from each other to be quiet when the other spoke, and then the collapse. It began as a compliment. Our residuals against the solar system's minor ephemerides dropped again, this time after we incorporated a term the Soliton people had begged us to try, a phase-locking parameter that let the resonance mimic an orbital mean motion when seen from rotating frames. To my surprise, and I record surprise here because it deserves to be remembered, the fit improved by a margin you could feel in your hands. Suddenly, the lattice was not just a structure, it was a participant in the solar system's dance, borrowing to and from orbital frequencies like a musician finding harmonies inside someone else's melody. That is what we published, in the language you know already from press releases and review articles. The phrase that walked out of our mouths and into the world was "near closure on a dynamic dark matter solution." In our private documents, the word was simpler, collapse. The scatter narrowed, the theory stopped wobbling, the floor felt closer to our feet. Not everyone agreed. Chiara reminded us that closure is an epistemic emotion masquerading as a result. Ortiz from Madrid added a term that widened our bars again and declared the widening a virtue. Rosa wrote, Don't fall in love with the residuals on a sticky note and stuck it to my monitor where it stayed long enough to become a superstition. We argued, revised, reran, replotted. The curve forgave us again. The mission profile for Gravis firmed around a rendezvous corridor. We would meet the lattice near the inner edge of the belt during its next approach, not to touch it, but to let it touch us, through accelerations so slight that in any other century they would have been indistinguishable from imagination. The bus would measure curvature directly, nodal by nodal, like a blind person reading a face with fingertips too patient to be human. The last weeks before integration felt like the quiet before surgery. We were past words and into lists. There was relief in that. Lists forgive doubt because they accept only check marks. Safety reviews, thermal tests, vibration tables that shook instruments as if trauma could be rehearsed. I stayed mostly out of the clean rooms. Hardware makes me clumsy with awe. Back in the control room, the residents behaved like a student who has finally noticed the exam is scheduled. It arrived when our model said it would. Its amplitude swelled as predicted. Its harmonics thickened and then thinned according to a schedule no one had told it about except, of course, the sky itself. The flocked paper feel of rightness grew under my fingertips when I scrolled the plots. I started sleeping again. On the night before the first integrated systems test, Rosa poured 2 fingers of something brown into paper cups and pushed one into my hand. "To nearly," she said. "To closure," I answered, and she grimaced like I'd told bad luck my address. "Fine," I corrected, "to corralling the wobble." We drank. The hum continued, precise and definitely indifferent. I kept waiting for the other instrument to drop, timing to drift, a mirror to sulk, a magnet to confess its affair with a power line. Nothing obliged. We had trained the machine well, the sky had decided to be readable, the mission had stopped being imaginary. The floor, for once, held. On a Sunday morning that tasted like strong coffee and emails from Europe, Kiara sent a note that made me sit up straighter, a new fit that produced a tiny but repeatable prediction. If the lattice really was phase-locking to select orbital resonances while maintaining internal symmetry, then during the next 2 weeks we should see a specific modulation in the second harmonic, subtle, like a fingernail tapping a glass in another room. If we saw it, the Soliton camp would have to admit the lattice more than a metaphor. If we didn't, my camp would have to admit the Soliton more than an analogy. Either outcome would have been a victory for sanity. Either outcome would have been good. We saw it, clean, twice. I didn't cheer. I don't do that in the lab. Instead, I wrote in the notebook, H2 modulation seen, model holds. Later at home, I poured a drink and allowed myself the secular prayer I reserve for such nights. Thank you for the curve that behaved. If there were foreshadowing in this story, I would point you to that sentence and draw a line under it. But there isn't. In Act 4, there is only good science, almost answers, and a mission rolling toward a launch pad with a patch that made engineers cry when they thought no one was looking. The collapse was our victory. Closure meant we could ask harder questions. The models almost worked, the numbers almost sang in tune, and the universe, our universe, looked briefly like a puzzle solvable by care. When I locked the control room door at dawn and stepped into air that would be too hot by noon, I felt relief heavy enough to carry. The hum had become a friend, the lattice a language I could read without translating every word. Gravis would go and measure the face we had traced from shadows. We would know whether the crystals in our minds grew in the dark where the sky keeps its secrets. I got into my car, watched a hawk tilt into a thermal that did not ask my permission, and drove home. The phone buzzed with a calendar full of rehearsals. The world had finally agreed with us. This was what dark matter looked like when it chose to move where we could follow. The collapse, I wrote later that evening, is not a weakness of structure. It is structure deciding what it wants to be seen as. We were so close to seeing it. Chapter 5. The Revelation. Gravis did not look like history. It looked like a bus everyone had agreed to ignore while it was parked outside and then secretly blessed when it pulled away on time. The feed from the integration bay showed a silver box with arms tucked in, instruments wrapped in the modesty of multi-layer insulation. Even the mission patch, a hexagon crossed by a simple arc, seemed embarrassed by the attention. We watched it because the hum would not change its mind for us, and this was the only way we knew to ask a question without guessing the answer first. The launch windows slid until they didn't. The rocket behaved like a professional. I was at Livingston sitting in the control room with a small crowd of data people who don't clap for fire because they prefer to clap for numbers that come back long after the smoke. Gravis rose, the camera lost it to cloud, the network caught it again, and then it was only telemetry, which is our favorite kind of poetry. I slept a little that week. The resonance stayed on its schedule, modulating exactly where we expected. The world had grown used to waking up to articles about dark matter lattices. Teachers assigned our preprints to students who would meet each other 10 years from now and start arguments about how we got some detail wrong. I took long walks, held my breath at nothing, and tried to imagine the sound of quiet in a place where the lattice was all that touched you. Gravis's outward spiral was not cinematic. The mission dashboard showed delta V expenditures like a bookkeeper. The first checkouts returned green. The cold atom interferometers cooled as advertised. The accelerometers turned their faces to quiet and listened. When the bus fired its microthrusters for a trim burn, the plots hopped and then forgave us. The flight dynamics team stopped wearing their lucky shirts. That's how you know a mission has left superstition behind. The rendezvous corridor was a region, not a point, a shallow trough in a corner of parameter space where the lattice's inward leg would cross the bus's outward reach if both of them behaved like our model said they would. That phrasing used to be a hedge. On the morning we entered the corridor, it felt like a promise. The resonance's amplitude peaked exactly where Kiara's fit had predicted. The second harmonic's fingernail tap danced on schedule. The third overtone, it still pleased me to write that phrase, was present at the edge of our band, less rumor than testimony. I was on the midnight shift, someone has to be, tracking the bus's updates between injections at the detector and text messages from Rosa about a glitch in an unrelated magnetometer that would have been a crisis any other week. On my second cup of coffee, the first real curve arrived. The bus's onboard accelerometers reporting a deviation from Newton that no one had preloaded into the mission plan. It was small, a breath against a window. The sign was negative where we expected positive. The error bars were honest and unflinching. I pinged the mission channel. Seeing net accel residual minus 3.2 times 10 to the minus 12 meters per second squared on sensor A3, persisting across 90 seconds. Cross-check? The answer came less than a minute later from a flight dynamics engineer in Darmstadt. Confirmed on our end, A3 and A4 agree, likely entering shallow gradient as modeled. Stay chill. Stay chill is an instruction worth writing on a national flag. The gradient deepened. It wasn't a cliff. It was a field that gathered without touching. Gravis's thrusters whispered and then stopped whispering. The bus tipped slightly into the trough like a person leaning to hear better. All of this would have been an acceptable love letter from a dark matter lattice, a gentle pull, an odd sign, a curve we could fit. We had primed ourselves for that flavor of strangeness. What we were not ready for was the reflection. Gravis carried a calibrated gravity pulse generator, a foolish phrase for a tiny device that altered the bus's mass distribution by a whisper and measured the resulting acceleration at absurd precision. It was designed to sample the local curvature by tapping it very softly, then listening for the room to answer. We sent the first tap, 3 cycles at a prearranged pattern, a prime-numbered spacing no one would mistake for natural drift, and waited the expected interval for the accelerometers to report how the room had shrugged. The report arrived early. The return signal came back not as a softened echo from the local gradient, but as a crisp inversion. Our taps repeated back at us, clean and slightly faster than physics owed us. Rosen from timing asked if we'd mislabeled the packet. Kiara wrote, "Check latency, check latency, check latency," as if saying it 3 times could make the universe admit to a clerical error. We checked. The timestamps were perfect. The bus had tapped a surface that tapped back. We ran the pattern again. The return changed, still a repetition, still early, but with the second cycle adjusted, as if the surface had been taught our rhythm once and wanted to improve its timing. Adaptive reflection? Someone typed into the mission channel, and then deleted it because the phrasing sounded like science fiction in a room that did not allow it. The third tap came out of the bus like an apology. The return arrived like a correction. The room knew how we were drumming and preferred we drum this way instead. I did not speak. I stared at the curve until it decided to group itself into plausibility. Rosa arrived in the doorway and did not cross the threshold, as if the room were a ritual she could disrupt. Her face had the expression I've only seen during earthquakes. "What?" she said, which meant everything that "what" can mean. "They're sending us back our own pulse," I said, and hated the pronoun the moment I heard it. I amended to, "The field is." She didn't argue. She sat, and we sat, and the next set of telemetry performed the same small miracle, indifferent to our vocabulary. If you want to understand what denial feels like when the numbers stop obeying your grammar, imagine a long hallway of well-lit doors and one door at the end that refuses to be the hallway's end. We opened every other door again, just to be sure. Timing, clean; orientation, nominal; thermal, flat; compensators, online; noise, blessedly boring. Every door showed us the same hallway. The door at the end waited. The bus moved deeper into the gradient. The accelerometer's residuals grew. The pulse generator whispered again, and the return spoke back. Better this time, as if our taps were a language and the room had spent its spare time learning it. Someone in Darmstadt said the word mirror. Someone in Pasadena said the word trampoline. I wrote neither. I wrote surface, with the question mark leaned so hard it fell into the margin. The sunlight instruments showed nothing new. The thermal cameras saw black on black. The magnetometers told jokes about boredom. The only thing alive in that corner of the sky was the shape defined by our own asking. An hour later, Gravis crossed an internal threshold none of us had known existed. The accelerometers reported a sudden orderly change in basis, a rotation of the local gravitational field into an alignment that simplified residuals in a manner only perverse equations would admire. The bus had not turned. The field had. The room had rotated the furniture to make our walking easier. One of the flight engineers laughed once and then said he needed air. The rest of us waited for a violation, a jitter, a slip, a confession in the noise that would let us fold this prodigy back into idiocy. It didn't arrive. We pushed the bus forward. Forward is a privileged human word. What we did was move in a coordinate that made the telemetry more informative. The gradient smoothed to a slope so perfect a calculus student could cry. Then came the first image. Gravis carried two narrowband imagers, not for light we could see, but for distortions we could infer. Tiny starfield differentials that reveal curvature the way heat waves reveal roads in summer. The pipeline that reconstructs such images is not instant. It is patience turned into software. But the first pass rendered within an hour, and the lab, 3,000 miles away from whatever the bus hovered near, learned what it means to see something that should not exist. At the center of the frame was nothing. Around that nothing was a contour, a lensing edge that traced a shape no astrophysical process would choose, a plane. Not a mathematical plane. All planes are mathematical, but a flatness extended across kilometers, so clean that starlight bent in agreement along its border. The pipeline painted its outline in pale gray and tried to call it a boundary. Rosa said, "No." Then she said, "Yes." Then she said something in Spanish that tasted like prayer. We processed again. The plane held, an abrupt shift in curvature like the edge of a glass dipped into water. Beyond it, the starfield bloomed and whitened in ways we could predict from simple lensing. Within it, there was a structured darkness, reliefs outlined by how they bent the background, a tiling that obeyed a symmetry not present in the universe had we not just asked it to demonstrate one. I thought of all the words we had used these past years to avoid the ones that now wrote themselves across the plot: node, filament, lattice, machinery. The border of the plane showed a faint ripple, creases that traveled faster than our software wanted to admit. When we ran our calibrated pulses again, the return landed not only early but phase-aligned to the ripple, like a musician joining a song they had been alone in hearing. The mission channel stopped typing incomplete sentences. An avalanche of fragments took over. Seeing consistent plane edge across 3 frames. Starfield offsets match predicted curvature under flat boundary. Return pulses now locked to incoming modulation. No thermal emission in the usual bands. No EM, nothing. We are looking at a surface. There is a moment in physics when the pride that kept you honest becomes the thing you must overcome. We had built so many gates in our minds to prevent ourselves from walking into fantasy that now, faced with an object whose only plausible name belonged to fantasy, we hesitated. It hurt to say it. I didn't say it. I wrote instead, "The field is reflexive. The boundary is planar. There is coherent modulation in response to our tests. It adapts." Then a line under "smaller" in handwriting I would not have recognized as my own. It is built. No one corrected me. No one said the word. But we all understood what had changed. The belt anomaly was no longer an equation. It was a thing. The bus edged closer. We sent a longer pattern, a prime sequence followed by a deliberately ugly stub. The return arrived without the stub. It arrived with our mistakes corrected. "Stop," someone wrote, which is not a mission command but a human one. We didn't stop. The schedule was the schedule. We had built too many safeguards to trust the romantic impulse of restraint. The bus maintained distance. It did what it was told. It tapped again. The return aligned itself like a compass needle finding north in a room full of magnets. The next image showed structure within the plane. Not glyphs, not writing, not anything meant for eyes. Grids with irregularities where the curvature spiked and sank. Shapes that answered our pings with micro-turns of slope. A system acting in a basis that made mass and time variables, not constants. The plane, a gravity plane, someone typed, and no one deleted it, behaved like a surface in the sense that it separated one regime of curvature from another, as a membrane separates fluids that prefer not to mix. We had spent years calling it dark matter. The thing in front of our bus used that phrase the way an adult uses a child's toy to explain a dangerous idea. It moved weight, it moved fallingness, it accepted our questions and returned them improved. "What are the odds this is natural?" a voice asked in the mission audio, voice flat as code. A long silence followed, full of typing and measured breaths. "Zero," Kiara said. She was not a person who liked that word. "This is control." The flight lead asked for consensus. No one wanted to be the first to say it out loud. Consensus emerged anyway in the language of instruments and constraints. We would hold distance, hover along the plane's edge, map the modulation spectrum, try patterns that had no human pattern baked into them. We would stop tapping words. We would tap noise. The plane did not care for our noise. It returned a basis set, as if proposing a language of pulses orthogonal to our own. The accelerometers registered tiny adjustments in field orientation, always in favor of clarity. Our gibberish went out, grammar came back. "It's teaching," Rosa said, and then shook her head, angry at herself. "No, it's establishing protocol." We stopped sending. For a full hour we just listened. The plane sang nothing unless we asked it to. Around it, the lattice's distortions rippled, not randomly, but as if a schedule had been declared that we were late to read. Farther out, other frames hinted at parallel boundaries, planes at angles to planes, like facets of an invisible polyhedron too large to draw from our little corner of it. When the next packet arrived from the bus, it contained a telemetry field none of us had expected. A set of automatically generated diagnostics triggered when onboard instruments detect persistent, structured input over nominally featureless gradients. The bus had decided within its narrow authority that it was being interrogated. The log showed timestamps that did not match our commands. Corrections had been applied to sensors we had not authorized. The room had reached across the table and moved our hand a centimeter to the left. Command authority remains ours, the flight engineer said, voice carefully neutral. But telemetry indicates external guidance on alignment axes. The bus is obeying because the math makes sense. I wanted to make a joke. I wanted to say something flippant about the universe finally agreeing with us. I wrote instead, "We are not alone in the control loop." I do not mean theology by that sentence. I mean the most literal thing a physicist can mean. Our instrument had been absorbed into a larger one. Our question had become a component in someone else's measurement. We pulled the bus back. It took more fuel than we had planned. The plane did not follow, if follow even applies to a surface. The return pulses continued to arrive on the timing it preferred, not ours. The hum on Earth did not change. The lattice kept breathing the way it always had. We were a fingertip against a cathedral door, and the door had taught our finger how to knock properly before closing itself again without moving. The first public statement about Gravis said nothing true. It said we had entered a region of complex gravitational gradients and obtained preliminary confirmation of lattice structure consistent with self-interacting dark matter. It said the mission was healthy and proceeding with caution. It said the next phase would focus on high-fidelity mapping. In the collaboration's private channel, the document that mattered had a different summary. We had encountered an adaptive planar boundary in curvature space that reflected and modified our test signals in a way consistent with control. The word artificial appeared in the appendix because we were cowardly enough to make the truth go to the back of the room and sit down. That night, I stayed at my desk long after the lights dimmed themselves into apology. Rosa dozed with a blanket over her knees and a screensaver pretending to be a sky. The monitors in front of me cycled through curves that had stopped being innocent. I scrolled back to the first time I'd written down the swell in a notebook and tried to remember how it felt to think low-frequency environmental swell periodic. Without hearing the undertone of a sentence I'd eventually have to complete. I didn't feel fear. That came later. What I felt was scale. The sensation that our finding had not opened a door but revealed that the room we thought was a room was a closet. The homey arrogance of believing the universe liked to be discovered had left me. In its place was etiquette. We had knocked on a surface. The surface had corrected our knocking. We were inside its patience, and we had been for some time. We sent one last pattern before the window closed, a series of taps spaced irrationally, their ratios chosen to deny easy symmetry. The return did not deny the symmetry, it offered one. It arranged our ugliness on a grid we could not have guessed without thinking in a basis where gravity is a craft material and mass is a verb. That was when Ortiz from Madrid, who had flown in to sit behind us and aged 10 years in an afternoon, leaned forward and said carefully, "It isn't dark matter." No one answered. We were already writing the next sentences in our heads, the ones that would turn discovery to confession, the ones that would ask the question that had been waiting at the end of the hallway: if it's built, by whom? And if it is a machine, what is its function? The plane held its position in the images, a quiet knife in a field of lensing. The bus drifted away, obedient to commands we issued with hands that trembled only when we looked at them. The hum on Earth remained the same. The lattice did not acknowledge us again. In my notebook, under a date I underlined twice, I wrote a sentence without adjectives. We have encountered gravity under control, then smaller, not ours. I did not go home. I do not know what time means in rooms that swallow it, but I know I watched the curve ride the baseline until my eyes begged for blinks I would not give them. I thought of the rabbit Rosa had once called an intern. I thought of the day we called this noise. I thought of the moment the bus tapped on a door and the door tapped back in a rhythm that made my ribs hurt. There was no message, no hello, no threat. There was not even an acknowledgement that we existed, except the courtesy of mathematics. The plane had taken our pulse and improved it. It had altered our alignment to help us measure it better. It had returned the world the way an adult returns a child's toy, cleaner, puzzled over, placed back in the child's hands as if to say, "This is how it works." We congratulated ourselves publicly on the first high-fidelity mapping of a dark matter structure. Privately, we wrote protocols with the word engagement in them and argued over what to do with a fact we could neither publish nor unknow. On my way out of the control room, past dawn, I stopped and turned back. The hum rose and fell through speakers that did not play it, because the sound had long since left the hardware and taken up residence in the head that insisted on hearing it. I reached into my bag, took out the notebook with its corners rounded by tired hands, and added a last line before sleep made lean on grammar. Discovery, a door, function unknown, ownership implied. If there had been foreshadowing, I might have written a warning. Instead, I drew a plane, a childish rectangle, and a small arrow approaching it from below, labeled with a single letter, us. Chapter 6. The Gravity War. For the first time in years, the hum changed. It did not grow louder, it gained articulation. A modulation ran through the bass frequency that no one on Earth had put there. The Gravis bus was already dead, or at least silent. The telemetry stopped as if the channel itself had been bent sideways. The hum, though, came home cleaner than ever, stripped of noise, carrying new harmonics that our models did not own. We told ourselves it was the field resettling, a rebound in curvature as the lattice adjusted to our trespass. We built that story because people need stories between heartbeats. The public never heard the word reflection. The press releases spoke of data loss, calibration errors, a pause in transmission. Only the collaboration's internal calls hinted at unease, and even then we used engineering terms for fear. A system response, a curvature correction, a feedback loop. Words you can hold with gloves on. When the first gravity plane appeared, no one recognized it. The reports from Chile and Tibet read like meteorology at first. Unusual lensing pattern, flat field refraction across low altitude. The satellite images were cleaner, lines of distortion moving in silence, shadows that had no source. In infrared, they were empty. In radar, they were mirrors. A week later, a commercial airliner vanished after crossing one near the equator. The recording showed a shimmer, a roll, then nothing but sky. The wreckage never fell. By the time governments noticed, there were dozens, thin planes of curvature sliding across the atmosphere, invisible except when they decided to be seen. They made no noise, shed no heat. They passed through cloud as if through thought. No radiation spike, no chemical trace, just the quiet rearrangement of gravity into new preference. We ran simulations until they became confessions. The planes moved as if controlled from the lattice region, each one a local reconfiguration of field lines. Their edges bent light in signatures that matched Gravis's last images. The universe had begun to write geometry with a steady hand. At first they spared infrastructure. Roads stayed level, buildings intact. Then people began to disappear in clusters, not explosions, simply absence. A team at Virgo captured one event on camera, a sheet of air rippling across a hillside. Where it passed, bodies folded in place, shadows lengthened, and then there was stillness. The hillside remained. The grass was uncut. The humans had been subtracted. The analysts called them gravity planes. The name stayed because it was exact. Surfaces of altered curvature, infinitely thin, moving with mathematical indifference. The planes swept methodically, overlapping, correcting. It took a day to map their routes and another to realize the pattern covered every continent. The lattice was tidying its workspace. I wrote in my notebook, "Not attack, maintenance." The world governments reacted the way organisms do when nerves fire pain. Too fast to think, too slow to matter. Militaries scrambled, satellites fell into orbits that no longer held still. Lasers missed because light itself bent away. Bullets, missiles, everything human designed to move under the old gravity lost meaning. In orbit, the first stations drifted toward new nodes as if drawn by gentle magnets. Astronauts reported brief weight reversals, then silence. From ground telescopes, their modules could be seen deforming into perfect spheres before vanishing like stones underwater. On the surface, cities emptied. No thunder, no flame, just wind finding new corridors through places where breath had stopped. The gravity knots arrived next, points of intense pull that appeared without warning. You saw them only by how they moved dust and leaves. When one passed through a street, cars folded like paper. People within 10 meters became brief flashes of condensation, spheres no larger than fists rolling away like marbles. Someone at ESA called them localized curvature singularities. Someone else called them errors being fixed. Both were right. I stayed at Livingston because leaving made no sense. The detectors still ran, though the data was nonsense now. A choir of curvatures arguing in registers too high for instruments built by mammals. The hum filled every channel. Rosa came back once more to sit beside me, silent except for the sound of paper as she turned notebook pages already full. We didn't talk about escape. We talked about integration constants. When the horizon fields appeared, even denial quieted. They rose from oceans like mirages, great shimmering domes where gravity's direction wavered. Ships approaching them tilted, slowed, and dissolved inward, hulls stretching into lines that never snapped. Satellite footage showed entire coastlines bending, water climbing the air in smooth sheets before returning as mist. The fields were boundaries, our world's edges being redrawn. No message accompanied them, no signal, no ultimatum, just geometry correcting itself. For a time, communication persisted. The network adapted to shifting orbit by brute improvisation. We traded numbers like talismans, how far the planes had reached, how many knots were cataloged, which regions had gone silent. The counts stopped meaning anything when the pattern filled the map. Every inhabited zone lay inside the correction grid. Rosa stayed until the Louisiana air turned strange, light falling sideways, rain refusing to curve down. She looked at the monitors and said, "It's everywhere now. They've finished the model." Then she left for the airfield. The next morning, the radio towers along that direction registered a distortion sweep. After that, nothing. I kept working because that's what a scientist does when faced with an unanswerable event. You take notes until the pencil breaks, then you sharpen it. The detectors still recorded something, spikes and silences alternating like breath. The planes were not random, they converged. The lattice overhead projected patterns that looked like convergence maps, drawing every vector toward the planet's core. For a while I believed they might collapse the world into itself, but the readings said otherwise. The mass stayed constant, the curvature changed. They were reshaping the gravitational field, not destroying it. The planet would remain, only we would not. The hum acquired harmony, not melody, harmony. Multiple frequencies weaving together in ratios too neat for natural systems. The signature matched the modulation Gravis had detected near the plane's edge. The same pattern now spanned continents. The lattice had extended its influence inward. Earth was inside the architecture. One evening, I stepped outside the control building. The berms stretched in their familiar lines, stars bent slightly wrong. In the distance, a shimmer crossed the tree line, flat, silent, bright, only because it stole starlight and returned it obediently. The plane advanced with a calm so total it felt like consent. I stood there longer than sense allowed. When it reached the end station, the metal walls sighed inward without breaking. The light around it refracted, and the station became a clean dent in air. I went back inside. The detectors still hummed, though the signals were no longer interpretable as waves. They were instructions being carried out. Across the channel from Pisa, Chiara's last message blinked unreadable. One fragment came through before the connection folded. "We are inside their calibration." I wrote it down. In the following days, the plane slowed. Gravity knots dissolved, their work finished. The horizon field stabilized as hemispheres touching at the edges like soap bubbles meeting. Inside their borders, gravity pointed inward from every direction, a planet-sized cradle. Objects drifted gently toward centers that no longer coincided with Earth's own. If anyone remained alive, they would have floated until the air thickened around them, lungs confused by weight that changed direction between breaths. I do not think anyone remained alive. The detectors ran until the last power grid flickered. The backup batteries held longer than their ratings. Physics has its moments of mercy. I spent those hours cataloging the harmonics, tracing how each plane's passage left a subtle, lasting shift in local G. Where it had passed, gravity was smoother, tidier, less interesting. The universe likes efficiency. It had found some. I thought about the question of intent, whether these acts were extermination or simple housekeeping. The data refused to distinguish. The planes avoided major magnetic anomalies, adjusted to preserve orbital balance, cleaned with precision but not malice. It was a surgical procedure performed by a surgeon unaware the patient was sentient. At dawn, or what dawn meant under refracted sky, the hum peaked. The overlapping harmonics phased into a single tone so low I felt it through the floor rather than heard it. Every instrument needle froze mid-swing. For a moment, gravity itself felt uniform, as if the planet had been perfectly leveled. Then the tone decayed, not fading but resolving into silence. The plane ceased. The horizon field steadied and became mirrors too faint to notice. The correction was complete. I walked the corridor between the arms one last time. The air felt wrong, light but thick, as though density had learned manners. Dust rose in slow arcs, indifferent to direction. The berms were smooth, the grass unmoved. Where Rose's footprints had been, the soil lay seamless. I reached the end station and looked for my reflection in the viewport's glass. It showed only the sky, curved, flawless, patient. Back in the control room, I powered the remaining console with what current the batteries allowed. The logbook lay open to the last page. I wrote as clearly as my hand would. Observation: completion of gravitational realignment across planetary surface. All biological structures absent. Planet stable. Gravity constant, smoother than prior. No detectable anomalies remaining. Then below that, a smaller note. We were the anomaly. Outside, the hum's echo lingered, a subaudible presence rather than sound, like air remembering weight. I listened until I could no longer tell if it came from the sky or from inside my own body. If there was any final act, it happened beyond perception. The lattice above adjusted once more, its filaments dimming as they drifted outward. The gravitational constant across all detectors ticked upward by a margin too small for human consequence, but large enough for instruments that no longer had anyone to read them. A quiet recalibration, a universe smoothing itself after erasing the roughness that had noticed. I stayed awake until the consoles went dark. The silence after that was perfect. I thought about Gravis tapping on the plane and the plane tapping back with better rhythm. I thought about how we mistook courtesy for curiosity. I thought about how discovery and extinction can share the same equation. When the light outside bent for the last time, I felt it rather than saw it. Weight left my feet. The chair drifted upward half a centimeter and hung there, as if deciding whether to keep me. I smiled because the data was still consistent. Then everything steadied, including me. The final entry reads, "The correction is finished. The lattice has reclaimed symmetry, no further motion observed." And then, one more line that I added as the pencil dulled, "They left the world cleaner." Thank you for listening to The Gravity Well.